Welcome back. We're going to continue our discussion on titrations. Now, in the previous video on titration, towards the end of that video, I discussed three unique graphs. Now, those graphs were not drawn to scale, and probably the ones I'll draw in this video won't also be to scale. What I mean by that is it's not drawn perfectly from a certain value to a certain value. And the pure intention behind that is just to help you understand the idea of the various titrations qualitatively and the effect of pH at equivalence point. Right? Now, I have four different graphs drawn here. Now, if you plan to take any professional exams such as MCAT or even GRE chemistry or any of the pharmacy or dental exams, you would have a higher chance of running into qualitative graphs like these versus math-oriented graph, because, you know, let's face the fact that you're not permitted to use a scientific calculator on several of these exams. So let's say if you understood the idea of titrant and a titrate. Let's look at the graph on the far left at the top. You have a strong acid with a strong base, right? So right away what that tells me is this is your titrate, right? That's the first thing that goes in the flask. And this is your titrant, right? So you're adding a titrant into a titrate, right? That means you're starting with an acid. And we recognize they're both strong, right? So we do expect to see a huge inflection point all of a sudden, right? Again, another thing I want you to recognize is we're adding a base to an acid. So we're starting with an acid. So our pH should go up, right? So let's draw it again. This is exactly very similar to the one we have here. You see how strong this inflection point is, right? The steeper portion is very, very strong. You know, I could have even made it more straighter, but you get the idea, right? It kind of is so long, right? You see the graph almost fills the entire graph, right? So if we say this is 7, then right at the middle is the inflection point. Now, I think, you know, a perfectly drawn graph using Excel would look a lot better than my hand-drawn graph on my virtual tablet. But you get the idea. Right in the middle of the flat portion is your equivalence point. If both are strong, then pH is right in the middle, and this is your equivalence point, right? So that's a qualitative questions people writing standardized exams usually ask. What's the pH of a strong acid, strong base at equivalence point? Well, the answer is 7. So they may not even give you a graph. They may give you a bunch of numbers, and all that numbers have no meaning if you actually understand what's going on. Again, this is your titrant, and this is your titrate, right? Because it's written first, and that's your titrant, right? Right. So you're adding an acid into a base, right? That means you're starting at a higher pH, and as you go down, the pH goes down, right? Now keep in mind they're both strong, so the graph's going to be going in the opposite direction. But the fact is you are going to get a strong inflection point, right? The graph literally, it's like a HD screen. The image just fills the entire graph, right? And your weak graphs are never like this, right? So again, I've done a terrible job drawing my perfect straight line, but if you recognize, it's still pretty flat enough, and the middle of the portion is right around here, and we're going to say this sort of is our 7. And so again, whether you're adding an acid to a base or a base to an acid, if they're both strong, pH equals 7 at equivalence point, right? Right. So weak acid plus a strong base. Again, so this is your titrate. This is your titrant, right? Now again, you're adding a base to an acid, but you must recognize that you're still adding a base to an acid, so the pH should go up. But the fact is the acid that you're starting with is weak, So the inflection point is not going to be as big. So the graph really doesn't take up a lot of space, right? It goes like this, right? So the flattest portion is your, and say the midpoint is here. So that's sort of is your midpoint. So say if pH was 7 here, you notice this is above 7, right? So pH is above 7 at equals point. Okay. And then weak base versus a strong acid. Again, this is your titrate, and this is your titrant. You're adding a strong acid into a weak base. So we're starting at a higher pH, but again, just like your weak component, whether it's not going to be as strong, right? You see the graph is not really filling the entire space, right? So if this was your 7, this is sort of your midpoint of this. Again, I'm not going to expect you to show me the midpoint because that's beyond the scope of this class. And so you see it's right here. So it's at equivalence point, okay? At equivalence point, pH is less than 7. So the take-home message that I want to take away from this is whether it's a strong acid versus strong base, pH equals 7 at equivalence point. Okay. And weak acid versus strong base, pH is greater than 7 at equivalence point. Okay. That is if you're adding a strong base into a weak acid. And if it's a weak base versus strong acid, pH is less than 7 at equivalence point. This is very important because as much as you should be good at doing math in a chemistry class, understanding the science behind it foundationally, more from a qualitative perspective, is just as important. All right. Now I've shown you the secret on how to understand these graphs, and there's no real secret. It's just I've shown you that this will be something you need to know if you plan to sit for any professional exams of any kind involving general chemistry material. All right, I'll see you back with some number-based problems. So stay tuned.